All right, we got an old friend back. We had this friend appear in chapter 10 too, and it originated in chapter 7. Use the duality transform to construct the electric and magnetic fields of a magnetic monopole QM in arbitrary motion and find the Larmor formula for the power radiated. Okay, well, let's recall what the duality transform was. E prime, CB prime, QE prime, and QM prime. Okay, similar to what we had to do in the with the chapter 10 problem is we have to set alpha equal to 90 degrees. That's what we're shifting to. And if that's the case, we see that E prime is equal to CB. So, and then we see that CB prime is equal to negative E. CQE prime is equal to QM, and QM is equal to negative CQE. Okay, so we have all those terms down, and now we can use these to translate the equations that we use to derive the power formula. Okay, again, 90 degrees, since we know that the electric and magnetic fields offset by 90 degrees, they're mutually orthogonal. So E prime then, the field that we want with respect to the magnetic monopole, E prime is equal to CB as given in the duality transform, but we know that B is equal to R hat cross E. So you see the factors of C cancel, no big deal. We have to now use R hat cross E, but we know that E here is equal to negative CB prime squared. So if we want to write E prime in terms of B prime, we have negative C R hat cross B prime. Okay, so we have our primes together. We like that. But we also know that B prime is equal to negative 1 over CE. Okay, but our E here was given from the point charge moving in arbitrary motion, which is why you see a QE here. And now what we need to do is transform that into the QM. So we take that point charge QE and transfer it to the QM. As you see, we have a couple of negatives there, so we can kind of get rid of those. And then that QM prime comes with a 1 over C factor. So we get a 1 over C squared in blue in the next line. And we use that to put in terms of mu naught and epsilon naught. Again, typical habit. And we get rid of those epsilon naughts. And so now we have everything that we want in terms of how we find the electric field from the magnetic field in this transition, and we had the B field with the terms of the point charge. That's pretty cool, can't lie, pretty cool. Now what we can say is that the power radiated, we had before that it was mu naught QE squared A squared over 6 pi C. But we know that QE can be modified to QM prime over C with the negative, but since it's squared, we don't really need to worry. So our power formula gets modified to mu naught A squared over 6 pi C cubed instead of C, and then QM squared. Again, that makes sense for, doesn't not make sense. It does make sense for the magnetic fields doing what they do with that 1 over C factor. So if we drop the primes, then we can tidy this up. The magnetic field gives us a mu naught QM instead of the QE over 4 pi, and then take everything else with the arbitrary motion. And then we see that E here goes to negative C, R cross B. Okay, so again, they flip roles in this duality transform, and power is given as such. That C cubed term is the main difference. And yeah, pretty cool. Quick problem, but definitely a fun one to play with.